Okay, good afternoon class. So in this video we're going to look particularly at the analytical geometry. We're still busy with the Metro Center Education Statistics paper. The paper that you guys wrote, okay. So let's go to this quickly. We are told that refer to the table below to answer these questions as follows. You got X and you got the Y, what's the name then? It says calculate the correlation coefficient for the table above. So for the correlation coefficient, or to calculate the equation of the least squares regression line, we need to, what's the name of calculator, program our calculator. So we press mode, okay, we press mode, that's going to write it out here. You press mode, then we press stat, it's number 3. I think for your guys' calculator is number 2, not so? It's number 3, for my calculator is number 3. And what we're calculating, the correlation coefficient belongs to the least squares regression line. So it's number 2. And number 2 is A plus BX. Now we enter the data. Okay. We're going to enter the data there. Alright, so in the X column we got 10, then 16, then 11, then 12, then, 32, then 24, then 21, then 19. Okay? The next column we have 17. 16 corresponds with 35. 35. 11 corresponds with 20. 12 corresponds with 23. 32 corresponds with 83. 24 corresponds with 59. 21 corresponds with 50. And 19 corresponds with 45. Okay? Then what do we press? Thereafter we press AC. All clear. Then we press shift. The number 1. So press AC. Shift. Number 1. Because on top of 1 you'll see the stat. Then we press 5 for regression. Number 5 for regression. Now number 1 is A. For the equation of least squares regression line. Number 2 is B, and number 3 is R. Okay. The question in 1.1 was for the correlation coefficient, which is your R value. So we have to press 3. Okay. We press number 3 equals. We get an answer of 1. Okay. What can be deduced from your answer in question 1.1.1 is that it's a positive, perfect correlation. It's perfect. Okay. You must say both for you to get that mark. Okay. It's either negative or perfect or positive. Okay. As you can see here, no sign in front, so it's positive. Then in 1.1.3 it says use your calculator to determine the equation of the line of best fit, the regression line, in the form of y is equal to a plus bx. Now, as you can see here, I already programmed the calculator, I've already got these values sorted. Not so? So we go here, we press shift, the number 1, 5 for regression, 1 for a. So that gives us negative 13. So y is equal to negative 13. Shift 1, 5 for regression, 2 for b, so it'll be positive 3x. Okay, so that's your equation of your least squares regression line. Equation 1.1.4, it says, give a positive value for x where it might not be a wise decision to predict the value for y using the line of best fit. So if you look at this here, you must give a value for x if you look at these values here, what is the lowest value for x here? 10. Can you see that? What value is this? 16. Huh? And our maximum value is 32. So if you use any value between 0 but less than 10, or any value greater than 32, it's not going to be a good value to choose from. Why? Because that will be an extrapolation. Okay, it will be outside the data that we're currently working with. You guys understand? So, you can give me any value less than 10, but a value more than 32 will be the correct value. Okay? And the reason there, I think they asked you for a reason as well. Explain your answer. The reason there is that that falls outside the data set, which is an extrapolation of the data. Okay. In question 1.2, we are told below is a cumulative frequency curve that represents the amount of time people spend looking at the screens each day. Okay, so we all can relate to this. Not so, some of us can relate more than others. Okay. Alright, so if you look at this here, without going into the questions, how many people are being surveyed here? 140 people, not so. What is these people that spends no time? Here you can see no people spend no time. Everybody spends some time. Okay, number of minutes on the screen during a day. The maximum is 150. But many of us, we spend more than that time. Not so. So this is probably when many people didn't know, or maybe they didn't have the smartphones. No? That time was only MCED. No? You didn't have to spend so much time on it. But anyway, this is how it goes. The first question says, in 1.2.1, how many people spend between 30 and 60 minutes on the screen during the day? So how many people spend between 30 and 60 minutes? So how many people is at 30? 20 people. How many people is at 60? 60 people. Can you see that? So what is the difference between the two? 40. So the answer we are looking for here was 40 people. Okay? What percentage? So how do we calculate percentage? The number over the total number times 100. Not so. So what percentage of people spend more than 120 minutes on the screen time per day? So more than 120. So firstly I must go see here. These are 120. How many people comes in at that? 130 people, not so. Or more. So it's that part of the graph we're looking at. So from 120 to 150, how many people is this? 130 to 140? 10 people. Not so. But they ask you for the percentage. So it's going to be 10 over the total number, which is 130 or 40? 140 times 100. So it's going to be 10 out of 140 times 100. Gives us 7.14. 7.14%. Okay. Let's carry on. Question 2. Question 2, we are told that 15 members of a basketball team took part in a tournament. Each player was allocated the same amount of time on the court. The points scored by each player at the end of the tournament are shown below. Determine the median of the given data. People, is this data in order? Yes. No? How many values are here? 15. So 15 divided by 2? 7.5. So it's the 8th number is our median. Not so. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 8. So 42 is our median, the middle number. Not so. The next question says, determine the interquartile range of the data. So in other words, we must work out the lower quartile and the upper quartile. We cross this out, There's 8 numbers here. No, 7. 1, 2, 3, 4, 5, 7. So 7 divided by 2 is 3.5. So it's 1, 2, 3, 4, 1, 2, 3. So that is quartile 1. It's 32. Okay, so quartile 1 is 32. And then it's 1, 2, 3, 4. So that is quartile 3. 1, 2, 3. Alright? This is, your median is also known as quartile 2. So for the interquartile range, it's going to be quartile 3 minus quartile 1, which is 46 minus 32. So 46 minus 32 gives us an answer of 14. So the interquartile. If it had asked you for the semi-interquartile range, I would divide that answer by 2. Okay. Next. Draw a box and whisker diagram. Okay, so I already put this up. Oops. Draw a box and whisker diagram to represent the given data. Okay. So the lowest value here is, sorry, 27. Okay. The highest value is 62. What's 27 minus 62? 62 minus 27? 62 minus 27 gives us 35. How many units are here? 1, 2, 3, 4, 5, 6. So there's easily 20 units. So I can divide this by, so I can make it 2 per unit. Okay? It starts at 26. So it will be 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, which covers basically. Not so. So 27 gets a dot. So that's 26, 27 is in the middle there. And 62 gets a dot. Okay. So what I do is I put 27 there and I put 62 here. Okay. Is it wrong?
Oh no, so we're asking if you start at 26, so you don't always have to start at 0.
At 0, no. Otherwise, in this case, you're going to have a lot of unnecessary wastage on that line, isn't it? Okay, now you learned something. I'm glad you're here today. Right, so what is this? 42. There's 42. It's a stroke. Quartile 1, which is 32, gets a stroke. And then 46 gets a stroke. Okay, and there's my box. And there's yours, my whiskers. Okay. Then it says in the next question, use your box and whisker diagram to comment on the points scored by the players in the team. Okay, there's many things you could have said. Okay, anything that you said would have been acceptable. I should have said comment on the skewedness of the dot. Okay, but if you now say whatever you say that is reliable and that you could pick up from the box and whisker, you got the mark. Okay. I think it was unfair to mark you down on that. So the distance between 46 and 62 is 20, not so? Whilst from 42 to 27 is how many units? 42 minus 27 gives us 15. So that means to say that is larger, not so? So the data is skewed to the right. So since the data is skewed to the right, oh, that gap is bigger, so it's skewed to the right there. Okay. In question 2.2, it says here, the table below shows the height of trees in a forest. Okay. Yes?
So,
Yes?
how do you know that this could be
You see this gap here is larger, then it's skewed in that direction. The tail is long on this. Okay? So the graph is lopsided on the right. Okay? Otherwise, if it's about the same value, then it's what we call symmetrical. So the dot is balanced. Okay? It could be skewed to the right, or you can say it's positively skewed. Otherwise, skewed to the left is negatively skewed. Okay. People in 2.2, we are told that the table below shows the height of trees in a forest. If the approximate mean of the heights of the tree is 5, calculate the value of m. So here we are given a distribution table. Okay. So how do we calculate the mean normally? We need to find the class midpoints, not so. So we say 2 plus 0 is 2, divided by 2 is 1. 2 plus 4 is 6, divided by 2 is 3. Then the next one is going to be 5, 7, and 9. So to calculate the mean, it's going to be 1 times m, plus 3 times 165, plus 5 times 290, plus 7 times 185, plus 9 times 75. And this must be divided by the number of numbers which are here. So it's 165 plus 290 plus 185 plus 75. That gives you 715 plus m. So it's 715 plus m. And that's equal to 5. Okay? So you can drop that. So what I do is I cross multiply. Okay? So this is simply going to be 5 into 715 plus m equals m plus. Now this I do on a calculator again. So it's 3 times 165 plus 5 times 290 plus 7 times 185 plus 9 times 75. 3915. Okay? So 715 times 5 gives you 3575 plus 5m. So that gives me 4m is equal to 3915 minus 3575. 340. 340 divided by 4 is me an m value of 85. Okay. So in our next lesson we will just carry on with the stats question. Here's just one question. We just answer this one quickly. Okay. So we don't have to do this in the next video. So basically what we have here is we are told that 200 new trees with a height of 100 and of 10 centimeters were planted. Okay, so you look at the heights given here. The height is in meters, whilst this height is in centimeters. Okay, so that is something you must consider. Once this has been recorded, it's given that. Now you see this number here, 915 plus m, which means to say they have included that 200 trees already. Can you see that? Alright. Plus m over I is equal to 1. So if you look at this here, what do you notice? What do you notice here? That this forms part of your standard deviation formula. Can you see that? But what are we shorting? If you go to your formula sheet, for your standard deviation, we are shorting. You must divide this by in here. Not so. So if you divide that side by in, you must divide the right hand side by in as well. Okay? I think we must do this in the next period. What do you guys did now? Okay, go. Go off your card before Miss. What's the name? Take my. Okay. So in our next lesson, we're going to look at this and we're going to carry on. People enjoy the rest of your day. Morning class.